this video, we are going to talk about the wonders of chemistry and to continue with simple experiments from household items. I'm taking a regular carbon zinc battery, regular D battery. I'm staying away from the alkaline batteries, and I'm just using a very much generic battery. And what I did with a hacksaw was I sawed the top. It would be like this, holding it, and very easy sawing the top. And then when you see, when I expose it, I am going to take out three parts. One is the chemical, this black chemical here, all right, and I'm going to accumulate that black chemical in the dish here, and I'm going to keep going around. Then I'm going to push this part out after I cut this a little bit more, and I'm going to push the zinc. This is a zinc cup, and that's all the metal zinc, and I'm going to be using that for one experiment. I'm going to be using the chemical for another experiment. All right, you can see underneath the cover is a cup filled completely made out of the metal zinc. It's entirely of zinc, and the reason why zinc is used in the battery is because zinc is an active metal, and that active metal is going to donate electrons. All right, and then the chemical inside is a paste, and the paste is going to transport the electrons. And in a battery, when something loses electrons, something has to be there to gain those electrons. All right, and here the center, or the positive, is a piece of carbon. All right, so it's carbon with a black electrolyte, which is all chemical, in a zinc cup. And what I'm going to do first is I'm going to show you that this chemical can do things. And what it's going to do is remove the oxygen from hydrogen peroxide. So if I have a few test tubes filled with 3%, this is store-bought hydrogen peroxide. We'll disperse it so we have even amounts. All right, so these are just test tubes filled with hydrogen peroxide. This test tube is a little dirty, so I'll use the second one here. And if I take a glowing splint and have a glowing splint ready, you will see that this black chemical is a very powerful catalyst that's actually going to remove the oxygen. I'll take a piece here and put that in. And the test for oxygen is a glowing splint. Right now the splint is glowing because the black chemical, which is called manganese dioxide, is removing the oxygen from the peroxide because it is a very powerful catalyst, and it's acting as a catalyst inside of the battery. So if you needed a catalyst, as I very often as a teacher do, I take batteries apart. And if I take a battery apart, I might have an entire bottle of catalyst that we could use for a variety of experiments. So look how the hydrogen peroxide is bubbling, and it won't bubble until the black chemical comes into contact. And when I spoon some in, you will see that the decomposition takes place, and I'm getting a very high amount of bubbling, and I'm proving that those bubbles are oxygen. Once again, I'm taking a piece of wood, and look how much oxygen is coming out, by the way, and I just put a very small amount in. You can see there is the test for oxygen. So, when teachers and chemists need chemicals, we might simply take a battery apart. Well, the second component of the battery is this zinc cup. This one has been washed out, and it's 100% the metal zinc. And we spoke before, I'm just going to take it and cut it into pieces. And you can see how metallic in nature it is. But I'm going to cut it into pieces because zinc likes to react with acid. And when zinc reacts with acid, it removes the hydrogen from the acid. So in one case, I'm taking hydrogen peroxide and I'm removing the oxygen with the black chemical called manganese dioxide. And in the second part of the battery, I'm taking the zinc and I'm cutting it into pieces so that I can take these pieces and place them into a test tube. And in that test tube, I'm going to add hydrochloric acid. Or actually, it doesn't matter which strong acid you use. I'm actually going to use sulfuric acid. So I'm using a cutter, all right? And now I'm taking several pieces of the cut cup, which again is the outside part of the battery. This whole thing here. And I'm going to do it twice. Take the rest of the pieces. I have more pieces here. Alright, so we have 2 test tubes. And now, some sulfuric acid, or any acid will work. And I'm going to see that these bubbles now are going to be very different, because these bubbles are bubbles of hydrogen. As you can see, if you look at it carefully through the transparent sulfuric acid, it is bubbling and getting a nice bubbling from both sides. All right, and here we're going to wait a few minutes, and I'm going to this time change the splint. And the test for hydrogen is not a glowing splint, but a splint that's burning. So the best way to accumulate the gas is to keep your finger on top until you feel the pressure, and you can see how it's bubbling. I can shake it a little bit, keep my splint going. All right, and I want to get a good accumulation of the gas. Enough yet. You can clearly see how it's bubbling. All right, so what I might do is just wait a few seconds, and we might want to just collect the gas this way, but that is pure hydrogen that's coming off. Of course, we can't believe it's hydrogen unless we test for it. All right, so the reaction is picking up speed because more of the zinc is being exposed. All right, I do feel the pressure of the gas on my hand, and you can see and hear that pop is the test for hydrogen. All right, now I have one more piece of the battery, and that piece of the battery is the carbon rod. That was the center part. Remember, it was right here. All right, and with that carbon rod, I am going to show the unique properties of carbon. I'm going to use it as a connector because this is a device called the conductometer. And of course, the conductometer is simply a battery connected to a special type of bulb. And when I touch the wires, you can see that the bulb goes on and it goes off. So whatever object I place between these two that would cause the bulb to light means that it has the unique properties like a metal. So if I took a metallic spoon and I touch both wires, right, you can see, actually it's the coating on the spoon, so let me try the knife. See if the knife will do the trick. All right, are we getting any lighting there? No lighting? It is lighting. Okay, but watch what happens when you take a piece of carbon, which officially should not be doing this because carbon is officially a non-metal. But when I put a piece of carbon there, you can see that carbon has unique properties. Can you see the light? Because carbon is a metalloid which sometimes behaves as a non-metal and other times behaves as a metal. So I was able to take a generic D-size battery. I was able to remove the electrolyte and use it as a chemical, which took the oxygen out of hydrogen peroxide. I took the zinc cup, I washed it, I cut it into pieces, and right now you can see that it's still bubbling in the acid because I got the zinc to take the hydrogen gas out of sulfuric acid. And then, rather than get rid of the carbon rod, I can use the carbon rod as an electrical connector, and I can complete a circuit by using a carbon rod. So I got three things. Instead of throwing this battery away, I have a lot of metal that I could use for experiments. I have a lot of chemical, and I have electrical conductors. So this is why chemistry is such an amazing subject, because there are so many things we can do to take store-bought things and household items, take them apart and use them for beneficial things, especially as I showed you today. Thank you.